Welcome back to another explainer. Today, we're tackling something that feels, honestly, a lot like modern magic. It's something that dictates almost everything we do in our digital lives, yet we rarely stop to think about it. We're talking about Wi-Fi. I mean, think about it for a second. You sit down, you connect to a network, and suddenly, boom, you have the entire world at your fingertips. But how does that actually work? Today, we are demystifying Wi-Fi and exploring the incredible, invisible highways that surround us all. I really want you to ponder this right now. How does a massive, high-definition video, literally gigabytes of complex data, vibrant colors, sounds, and motion, travel through thin air, punch right through the walls of your house, and land perfectly on your phone screen without a single physical wire attached? It sounds entirely like science fiction, but the reality is an absolute symphony of physics, hardware, and just brilliant engineering. All right, so here is our roadmap for this explainer. We're going to cover the physics behind these invisible waves, clear up a massive misconception about Wi-Fi versus the internet, look at the actual hardware, decode those frequency bands, and finally, we'll explore how modern traffic control keeps our networks running smoothly. Okay, let's jump right into section 1, invisible waves. Let's look at the physics that makes this all possible. At its core, Wi-Fi relies on microwaves. These are high-energy radio waves. It's actually pretty similar to old-school FM radio, just infinitely more complex because it's encoding computer data instead of just sound. Imagine two people holding a jump rope. One person starts moving their arm up and down continuously. That baseline motion, that's what we call the carrier wave. Now, if the sender suddenly jerks the rope to the right, a ripple travels down the line. To the person receiving it on the other end, that single motion to the right represents a binary 1. A sudden motion to the left, that's a binary 0. By rapidly manipulating the actual physical waves in the air, your router is sending millions of binary 1s and 0s every single second straight to your phone. And to pack even more data into these waves, modern Wi-Fi uses a technology called QAM. Think of QAM like efficiently packing a suitcase, allowing multiple bits of data to be squeezed into a single wave manipulation. Moving right along to section 2, Wi-Fi versus the internet. Before we get any deeper into the crazy tech, we absolutely have to clear up the single biggest consumer misconception about home networking. The crucial takeaway here is that Wi-Fi is not the internet. I know we use the terms interchangeably, but a Wi-Fi router simply creates a local wireless network. It allows your phone, your laptop, and maybe your wireless printer to talk to each other using those radio waves. But if you just have a router, you cannot reach Google. You cannot stream a movie. For that, you need a modem. The modem provides the actual physical connection to your internet service provider. So your router catches the Wi-Fi signal from your phone and then passes it through the modem out into the wider world. Which brings us nicely to section 3, routers and network cards. Let's take a look at the physical hardware doing all the heavy lifting. So let's look at our central hub, the wireless router. Inside that plastic box, an intricate pattern of electrons, which is your computer data, flows right into an antenna. And the antenna is where the real magic trick happens. It converts that electrical current into an oscillating electromagnetic field, radiating it outward as radio waves. Those waves travel across your living room until they hit your phone. Now, inside your phone is a WNIC, a wireless network interface card. Its own tiny antenna intercepts that specific radio wave, converts the radiant energy back into electricity, and your phone processes it as data. And this entire crazy process happens in just a fraction of a millisecond. Let's move to section 4, frequency bands. It's time to explore these invisible highways in the sky. When we talk about wireless communication, there is a very strict, fundamental rule of physics at play. You have a trade-off between coverage range and data speed. Lower frequencies, like the 2.4 GHz band, have longer wavelengths. They can easily punch through the walls of your house and cover a huge area, but they cap out at slower speeds. Plus, that 2.4 band is incredibly crowded with stuff like physical microwave ovens and Bluetooth devices. On the flip side, the 5 GHz and the much newer 6 GHz bands use higher frequencies. They offer massive multi-gigabit speeds and a perfectly clean signal. But because they have shorter wavelengths, they really struggle to get through solid objects like solid doors and brick walls. To make this super relatable, think of the 2.4 GHz band as a reliable, heavy-duty delivery truck. It's slower, sure, but it can travel huge distances and carry heavy signals right through the walls of your home. On the other end of the spectrum, the 6 GHz band is a high-end sports car. It is blindingly fast and gives you incredible performance, but it absolutely demands a clear, open road to operate. If it hits an obstacle, it just stops, creating a dead zone. This is exactly why advanced home networks use something called Wi-Fi roaming. It automatically and seamlessly switches your phone to a better access point or drops you to a different frequency band as you walk upstairs, keeping that sports car moving without you ever noticing a drop. All right, Section 5, Traffic Control. Let's look at how we actually manage the sheer chaos of a modern network. First, just a super quick history lesson to show you how rapidly this tech has scaled up. The IEEE ratified the very first 802.11 standards way back in 1997. By 1999, we got 802.1b. Fast forward to today in the 2020s, and we are now on Wi-Fi 6 and Wi-Fi 7, which unlocked that massive 6 GHz spectrum we just talked about. And obviously, alongside these speed upgrades, our security protocols have had to evolve too, with modern networks using WPA3 to robustly encrypt your private data as it literally flies through the open air. But here's the thing. Opening up a new highway lane and securing it isn't enough. We need much better ways to manage the traffic itself. Enter OFDMA. That stands for Orthogonal Frequency Division Multiple Access. Before this tech came along, a router acting as a delivery truck could only carry cargo for one user at a time. If you were browsing the web and your partner was streaming a movie on the TV, your devices literally had to form a queue and take turns, which is what caused lag. OFDMA totally solves this. It lets the router stop the queue, load up the delivery truck with multiple users' cargo at the exact same time, and dispatch it all at once. Under the hood, the system basically divides the entire Wi-Fi channel into smaller segments called resource units, or RUs. The router dynamically assigns different colored blocks of data, say a green block for user 1, an orange block for user 2, across both time and frequency. So it's essentially playing a high-speed game of Tetris to ensure that absolutely no bandwidth is ever wasted. And if OFDMA wasn't cool enough, we also have MU-MIMO, which stands for Multi-User Multiple Input, Multiple Output. Think of this like a seasoned football quarterback who can somehow throw 3 separate footballs to 3 different receivers at the exact same moment. The router calculates the specific channel characteristics for every single device in the room. It then uses beamforming to pre-code the data and fires separate directional beams of radio waves simultaneously from its multiple antennas, aiming them directly at your phone, your TV, and your laptop. Each device only catches the data destined specifically for it. It's just a remarkably clever piece of engineering. So as we wrap up this explainer, I want you to literally look around the room you are sitting in. Right now, there are millions of invisible, data-packed microwaves passing right through you every single second. And because these waves are constantly bouncing off objects and bodies, modern Wi-Fi can even be used for presence detection. It can literally sense your micro movements just via radio reflections. It's this continuous, invisible symphony carrying everything from global breaking news to your family photos. I really hope this gave you a brand new appreciation for the absolute magic of Wi-Fi. Keep learning, stay curious, and I'll see you in the next one.